Hey guys, welcome back to the channel. This channel, Everyday Science, is all about trying to learn various concepts of everyday science by practicing a lot of questions. In this video, we are going to solve this question on Leetcode regarding find candidates for data scientist position part 2. The difficulty level of this question is medium, and I'm going to share the SQL schema as well as the panda schema in the description box below. Okay, the question reads, we are given a table called candidates with three different columns, candidate ID, skill, and proficiency. The combined column candidate ID and skill is the unique key for this table. Each row includes candidate ID, skill, and proficiency level from 1 to 5. We are also given a second table called projects, again three different columns, project ID, skill, and importance. The combined columns project ID and skill is the primary key for this table. Each row includes project ID, required skill, and its importance 1 to 5 for the project. Okay. Leetcode is staffing for multiple data science projects. We are asked to write a solution to find the best candidate for each project based on the following criteria. First, candidates must have all the skills required for a project. Secondly, calculate a score for each candidate project pair as follows. Start with 100 points. Add 10 points for each skill where proficiency is greater than importance. Subtract 5 points for each skill where proficiency is less than importance. Okay. We need to include only the top candidate, that is the highest score for each project. If there is a tie, choose the candidate with the lower candidate ID. If there is no suitable candidate for a project, do not return that project. Okay, return a result table ordered by project ID in ascending order. Let's go through this example. Here we have various different candidates, their skill and proficiency levels. And if we look at the projects table, so we have two different projects, 501 and 502. So let's see for 501 who is the best candidate. So for 501, there are three skills that are required: Python, Tableau, and PostgreSQL. If we look at candidates, so candidate 101 has Python, Tableau, PostgreSQL. Candidate 102 has Python, Tableau, PostgreSQL. And candidate 103 also have Python, Tableau, and PostgreSQL. Now we need to calculate the scores. So basically it says if your proficiency is greater than the importance, then you get 10 points. If it is less, then you subtract 5 points. If it is equal, then you basically get 0. And you need to start with 100. So here, Python, the proficiency is 5. The required is 4, 3, and 5. So 5 is greater than 4. So 10 points for Python. For Tableau, if you look at it, the importance is 3 and the proficiency is 3. So 0. And then for PostgreSQL, proficiency is 4 and requirement is 5. So minus 5. So 10 plus 0 minus 5 is 5 and you start with 100. So the total score for 501 project candidate ID 101 is 105. Similarly, we can go ahead and do that for candidate ID 102 and 103. And that is what we get in your output. Okay. So to solve this question, what we need is, because we need the importance column as well as the proficiency column, because that is needed to calculate the scores. What we can do is we can join these two informations, join these two tables using the skill column, that for every project ID, let's see who all candidates have that skill. So let's start with that. So what I'm going to do is, from this table called projects aliased as P, let us perform a left join of the another table that we call candidates using the column aliased as C, using the column skill, right? Using skill. And then what we are going to do is, let us keep all the columns here, right? Let's see what do we get by doing this. Okay, if we look at our output, let me just, drag it to the left so that it's easier for us to visualize. So if we look, so we have skill, project ID, importance, candidate ID, and proficiency. Now, once we have this, what we can do is, for every project ID and candidate ID, we can try to calculate the scores, because ultimately we need the best person for the project, right? So how can we go ahead and do that is, from this, let us group by the project ID. Project ID comes from projects table. So P dot project ID, and then candidate ID, which comes from the candidates table. So C dot candidate ID. And what we should do is, let's return this, because what we are doing is we are also calculating the total score for each project and candidate. And we are also going to calculate how many skills we have for each candidate. Okay, so once we have these two columns, we are returning these two columns, we are going to perform the scores, right? So now if we look at this, how are we need to calculate the score? Start with 100 points. So what I'm going to do is 100 plus, and now you need to do some case when statement. So what we're going to do is case when, and let me just drag it to the left again. So case when proficiency is greater than importance. So C dot proficiency is greater than P dot importance, then you assign 10 points. When it is the reverse, let me just copy this. When this, and it would be easier for us. So when this happens, okay, when C dot proficiency is less than importance, then you assign -5, else you assign 0, and since you started a case when statement, you end it, and then basically you need to perform the sum, right? So sum of this entire thing, and that should be aliased as score, right? And then what we can also do is, if I just drag it above and to the left so that it's easier for us to visualize, what we can do is, since we are grouping by every project ID and candidate ID, if we count the skill, then that is also going to give us, okay, this particular candidate has how many different skills, and where would that be helpful? Look at the first condition, right? The first criteria. Candidates must have all the skills required for a project. So if we get the total count of the skills of the candidate and compare it with the projects table to see whether all those skills are present in the projects table, that means that candidate has all the required skills of the project and can be considered, right? So what I'm going to do is, after calculating the score, we can also do that, hey, count the skills, right? So count C dot skill, that is skills of the candidate, and let's alias this as skill count. Now let me go ahead and run this. Let's see what do we get. Okay, so it says wrong answer, obviously, because right now it's not complete, but let me just drag it to the right so that it's easier for us to visualize. Okay, so now what we have here is, for every project ID and candidate ID, the total score has been calculated as well as the number of skills of the candidate, right? So for example, for project ID 501, 101 candidate has total score of 105 and total skills are 3. Okay, once we have this information, what we can do is, we can save this entire thing in a common table expression. So with CTE as, this entire thing goes into parentheses, right? And then what we are going to do is, from this common table expression, now what we need to do is, we need to go ahead with the first criteria, right? Right now we were mostly working with the second one, that calculate the score and all that. But we also need to make sure that candidate must have all the skills required for a project. How can we do that? So from this common table expression, what we have is, we have the project ID, candidate ID combinations, their scores and skill count. So if we do this, let us keep only those rows where the combinations of project ID and skill count is in, right? So in from this table, right? So from this projects table, if we group by the project ID and get a count of the skill, that is going to tell us that yes, for every project ID, these are the required number of skills and whether those candidates have that or not. So what I'm going to do is, from the projects table, let us group by the project ID and return me the project ID and the count of, right? So let me just bring it down, count of the skill column, and that is going to be the total number of skills required for this particular project ID. And then what we are going to do is, let us return everything from the common table expression. So right now we have about 3 and total 6 rows. But if I run this, it is going to filter it out. So now if I look at it, it only says that there are 4 different rows. So 501, all 3 candidates satisfy all the required skills of the project. But for 502, only candidate 102 does that. Let us, check this manually. Here, for it says for 501 requires Python, Tableau, PostgreSQL, and we saw that all the three candidates have that. Fair enough. For 502, it requires Python, Tableau, and R. However, if we look at 101, they do not have R. 102, Python, Tableau, and R is available, and 103, Python, Tableau, but no R. So you see, that is how this code is working. So once we have this, what we need is we need the best candidate, right? And how to have that best candidate? Highest score, and if there is a tie, then the candidate with the lower candidate ID. So what we need to do is we need to rank. So let us perform a rank using the dense rank function, because there could be ties. So dense rank over, and then what we are doing is for every project we need the best candidate. So partition by the project ID, and then order by the score in descending manner, and if there is a tie, by candidate ID in ascending order. And let's delete this as rank. Let me go ahead and run this. Let's see what do we get in our output. So here we have the ranks. Okay, now what we can do is we need to keep only the best one. So let us save this entire thing in another common table expression. So CTE2 as this entire thing goes into parentheses as well. And then what we are going to do is from this common table expression 2, let us keep only those rows where rank is equal to 1. That means it's the best candidate. And in our output, what all columns do we require? We only require the project ID, candidate ID, and score. So let us return these columns: project ID, candidate ID, and score. And the final output should be ordered by project ID in ascending order. So ordered by project ID in ascending order. Let me go ahead and run this. Let's see what do we get in our output. So yeah, this says accepted. If we look at our output is same as expected output. Let me go ahead and submit to see pass all the test cases. Yeah, this is accepted, and this is how we do it. So yes, very tricky question. What we basically had to do was, firstly, what we did was we joined the projects and candidates, because all the required columns are distributed among these two tables. So we use the skill column to get, okay, for every project and skill that is required, who all candidates have that. And we calculated the scores based on their proficiency and the requirement in the project. And we also performed how many skills each of those candidates have. Once we had that, then what we did was, for every project ID, we try to rank based on the score in descending manner and candidate ID in ascending order, and kept only those rows where the candidates have all the required skills in the project. And then once we had that entire information, we kept only the best one. So yeah, this is how we do it. Let me know if there's a better, more efficient solution to solve this question. Let the solution be in the comment section below, and I'll see you guys in the next video.